So, hello students. Today we are going to see this topic types of microprocessor. So, before going into that, do you know there is a small passage? So, if 5 volt is applied to 5 volt is applied at one end of a wire, the other end also can receive 5 volt. In the same way, the buses are wires and the binary data are voltage. Okay, so 5 volt as 1 and 0 volt as 0, and these buses can simply pass the data as voltage from one end to another end. Okay, so not only in CPUs, in motherboards also you can see so many buses running under the motherboard. Okay, so this motherboards can pass data by using this voltage only. Okay, so at one end of the bus they will be applying 5 voltage current. So if we receive 5 voltage at another end, then it is considered as 1. If no voltage is received, then it is considered as 0. So by this way, most of the not most of the all of the communication is being done inside the computer. So first of all, we are going to see this types of microprocessor. Microprocessor can be classified based on the following criteria. So there are two things here: the width of data that can be processed, the instruction set of the microprocessor. So first of all, we'll see the width of data. So classification of microprocessor based on data width. Depending on the data width, microprocessor can process instruction. The microprocessor can be classified as follows: 8-bit microprocessor, 16-bit microprocessor, 32-bit microprocessor, and 64-bit microprocessor. Classification of microprocessor based on instruction set. The size of the instruction set is another important consideration while categorizing microprocessor. Initially, microprocessor has very small instruction set because complex hardware was expensive as well as difficult to build. As technology had developed to overcome this issue, more and more complex instructions were added to increase the functionality of microprocessor. Let us learn more about the two uh, types of microprocessor based on this instruction set. So there are two types of microprocessor based on the instruction set. One is reduced instruction set computers, and the other thing is complex instruction set computers. So this reduced instruction set computers have CPUs or microprocessor that will have limited number of instructions to do the activities, but this complex instruction set will have more number of instruction for different activities. So mostly the computers or the CPU that we use in our computers is uh, is a type of complex instruction set computers. A small scale embedded system like biometric reader and single board computer and small calculators will have this reduced instruction set computers. So RISC stands for reduced instruction set computer, that they have small set of highly optimized instructions. Complex instructions are also implemented using simple instruction. Thus, thus reducing the size of instruction set. Examples of RISC processors are Pentium 4, Intel P6, AMD K6, and K7. Complex instruction set computers. Uh, they supports hundreds of instruction. Computer supporting CI SC can accomplish a wide variety of tasks, making them ideal for personal computers. Examples of I, CISC processors are Intel 386 and 486, Pentium 2 and Pentium 3, and Motorola 68000. So next topic is memory devices. So a memory is just like a human brain. It is used to store data and instructions. Computer memory is a storage space in the computer where data and instructions are stored. There are two types of accessing methods to access the memory. One is read and another one is write. There are sequential access and random access. Uh, in sequential access, memory is accessed in orderly manner from start to end, but in random access, any byte of the memory can be accessed directly without navigating through the previous byte. Different memory devices are arranged according to their capacity. Speed and cost are as shown in figure 3.6. So here there is a diagram. So it is a triangle. At the top most of the triangle you can see the cache memory. Next to it is main memory, and next to it is hard disk. So here there is a, in the left hand side you can see an arrow mark facing upwards, saying that smaller capacity, faster accessing time, and higher cost. So when you move from bottom to top, the capacity of the memory will be very low, but accessing time of the memory will be higher. And in the right hand side you can see a arrow mark from top to bottom, and it is showing that larger capacity, slower accessing time, and lower the cost. So when you move from top to bottom, the size or the memory capability will be high, but accessing time is very low. So if you want to access a byte, it takes larger time. So and you can see that the cost is also very low here. So first of all, we are going to see this random access memory, RAM. The main memory is also known as random access memory. This is available in computers in the form of integrated circuits. It is placed in the computers where operating system, application software, and the data in current use are kept temporarily so that they can be accessed by the computer's processor. The smallest unit of information that can be stored in computer memory is called a bit. The smallest unit of information, the memory can be accessed by a collection of 8 bits, which is called a byte. The byte are referred as capital B. If a computer has 1 megabits of memory, then it can store uh, 10,48,576 bytes of information. Hence, 1 MB is 1024 KB and 1 KB is 1024 bytes. So you can see that 1024 into 1024 is equal to 10 lakhs 48,576 bytes. RAM is volatile memory, which means that the information stored in it is not permanent. As soon as the power is turned off, whatever data that resides in the RAM is lost. It allows both read and write operation. Types of RAM. There are two basic types of RAM: dynamic RAM and static RAM. These two types differ in the technology they use to hold data. Dynamic RAM, being a common type, needed to be refreshed frequently. Static RAM needs to be refreshed less often, which makes it faster. Hence, static RAM is more expensive than dynamic RAM. Read-only memory. Read-only memory refers to the special memory in the computers where pre-recorded data is at manufacturing time, which cannot be modified. So read-only memory refers to the special memory in a computer with pre-recorded data at manufacturing time, which cannot be modified, which means that when we produce this read-only memory, only at the manufacturing time they can record data. After that, they cannot be able to delete it or modify it. So this is a uh, process. Okay, the stored programs that starts the computers and perform diagnosis are available in read-only memory. Read-only memory stores critical programs such as program that boots the computer. Once the data has been written onto the Rom chip, it cannot be modified or removed and can only be read. Rom retains its contents even when the computer is turned off, so Rom is called a non-volatile memory. So volatile means the data that resides inside the memory will be erased and it is temporarily holding the data, but non-volatile means the content of the memory will not be deleted forever. Next is programmable read-only memory. So programmable read-only memory is also non-volatile memory on which data can be written only once. Once a program has been written into a PROM, it remains there forever. Unlike the main memory, PROM retains their content even when the computer is turned off. The PROM differs from ROM. PROM is manufactured as a blank memory where ROM is programmed during the manufacturing process itself. So PROM programmed as a PROM burner programmers or a PROM burner is used to write data to PROM chip. This process of programming PROM is called burning the PROM. So this is an important 2 mark question. What is the process of burning PROM? Okay, so you should have known the answer. So it is a process of writing the data into the PROM chip. Okay, next is erasable programmable read-only memory. So erasable programmable read-only memory is a special type of memory which serves as a PROM, but the content can be erased using ultraviolet rays. EPROM retains its contents until it is exposed to ultraviolet light. So the ultraviolet light clears its contents, makes it possible to reprogram the memory. And EPROM differs from PROM. Um, PROM can be written only once and cannot be erased, but EPROM are used widely in personal computers because they enables the manufacturer to change the content of the PROM by replacing with updated versions or erase the content before the computer is delivered. So here you can see that this is the EPROM chip. In the center of it you can see a small sensor that will sense ultraviolet rays. So when this chip is exposed to ultraviolet rays, the content of the chip will be removed. So do you know most of the EPROM chips have transparent transparent area at the top surface which is covered by a sticker. If it get removed, the ultraviolet rays in the sunlight may erase the content. So electrically erasable programmable read-only memory. So electrical erasable programmable read-only memory is a special type of PROM that can be erased by exposing it to the electric charge. Like other type of PROM, EEPROM retains its content even when the power is turned off. Compared with all the types of ROM, EEPROM is slower in performance. Okay, So compared to all other ROMs, EEPROM is somewhat uh, very less in performance since it is using electrical signals to erase the content or program the content in EEPROM. Next is cache memory. The cache memory is a very high speed and expensive memory which is used to speed up the memory retrieval process. Due to its high cost, the CPU comes with a smaller size of cache memory compared with the size of main memory. Without cache memory, every time the CPU requests data, it has to fetch from the main memory, which will consume more time. The idea of introducing cache is that this extremely fast memory would store data that is frequently accessed and, if possible, the data that is closer to it. This helps to achieve the faster response time, and the response time refers to how quick the memory can respond to read and write requests. Figure 3.8 shows the arrangement of cache memory between the CPU and the main memory. So here it is the diagram. So this cache memory is a temporary small size memory. So it will retrieve the frequently used data from the main memory and temporarily store it in its cache memory. The CPU uses this cache memory for accessing the instructions so that you should not travel long time and wait for a long time to uh, receive the data. So the data will be available to the CPU next to it. So with this, we'll finish the class today. We'll see the rest of the things in the next class. Thank you, students.